Neil, you've got a great business here. Thank you for opening your doors to us today. We've come to look at this FANUC machine. It's been a very impressive installation here. Why did you buy the machine to start with?
I bought the machine because it was a cost-effective solution to solve a logistics problem I had.
And what was that logistics problem?
Originally I was manufacturing the majority of my parts in Taiwan, where the majority of the bike industry is based. And the lead times when I started were very short, but they slowly over the years got longer and longer and longer, up to about 7 or 8 months in some cases.
So you've now bought a lot of your component manufacture back in-house, and you've become more productive as a result of this machine. It would be good to find out in a kind of tangible, summarised way how much more productive you are now as a result of this FANUC ROBODRILL.
When I was prototyping the pedal systems, originally we were using a traditional 4th axis machine and manual loading with a 2-op process. By moving from that machine to this machine, we reduced the cycle time for 600 pedals from around 3.5 weeks to 3 days, and the human time has gone from 3.5 weeks of human shift time to about an hour per day, so a total of 3 hours.
Hang on, my brain is trying to compute here. That's probably about an 85% improvement in production.
Yeah, it's made us from manufacturing a niche product, which we'd have to sell at a higher price, to competing with time on level pegging. In fact, we're actually manufacturing for other people to the same prices and better quality levels in Taiwan because of the machine and the capabilities.
And before you actually bought it, was your expectation to get to that level of productivity?
My expectation was to streamline the process and get rid of any problems with staff and make it really consistent. The upside to the machine is it's double the RPM I was expecting, it's got better finish, it's fast, everything about it has just impressed.
So it's the FANUC ROBODRILL, and this particular model is the D21MI A5. Can you tell us what speed it actually runs at?
The spindle runs at 24,000 RPM. It's a BT30, and I presumed when I first bought it that you couldn't take big cuts with it, but we hammer it around, we do big feeds on it, we do big cuts on it. We mostly cut aluminium.
So were you of the belief originally that maybe the BT30 wasn't going to give you the same as the BT40?
When you read around, the sort of general rumour on the street is that BT30 is a bit flaky. To be honest, if nobody told me this is a BT30, you wouldn't know. I run it just like a BT40, slam the tools in nice and hard and cut really fast. Because
there has been some big improvements made in the BT30 tooling and the capabilities of BT30 machines.
Definitely.
So this is a completely integrated solution, is it, that you bought as one?
I originally was looking for a robot provider to upgrade an original machine. But it became so cost effective because FANUC do the machining, they do the 4th axis tables, they do the robot and the integration all in-house. It's just nice and easy, turnkey project. The whole system was delivered as one, as a proven product.
Because the 4th axis table on this machine's fast as well, isn't it? They're direct drive tables?
It's a FANUC direct drive table. You can barely see the thing spin round because we machine one side and then flip it over, machine the other, and if you watch the video of it spinning around, it's pretty impressive.
Now talk to me about energy consumption as well, because I know you looked at this in quite detail as well.
When we got the machine, we started running it. I knew that they were more efficient, but when we actually investigated on the machine, it's so low cost to run, around 30 to 40 pence per hour just on the spindle. It's virtually nothing.
And how would that compare to another machine tool that you may have?
The other machine tools, from what we've measured before, it's about 1/3 of the power for what we're doing. So there's a lot of spinning up and spinning down and short cut times on cutting aluminium.
That is a big saving. Sometimes it's overlooked, but if you're running this machine like you are 24 hours a day, it all adds up.
We run it flat out. We run it for weeks at a time without stopping because we can just load it up, 28-hour cycle time. So the energy cost, although it's not a major factor in buying the machine, is a really nice, keeps bringing me back to thinking about buying a second machine.
What would you say then to another engineer that might be watching this video and he thinks, well, yeah, but look, you're doing hundreds of the same components, you're not changing from part to part. If you did need to change to another component, is it easy?
We've designed 4th axis tooling with Saluki in Leicester. So everything's on dowels. You just swap out the tooling, swap out the trays, swap the robot grippers. It's all very quick and easy jobs to do. And then you put in your new program and a new robot program, press go, and you're making a new design on a new profile.
Okay, I can hear this whirring away in the background. What I want to do now, Neil, is for you to talk us through the process of machining, because it is very, very impressive.
Here we're doing M4 thread tapping with a roll tap, and it's 21,000 RPM with about 1,000 feed on it. We did the lower feed than I'd normally do, purely for reliability, because we've done hundreds of thousands of holes with this drill already, which keeps plunging it in. The fourth axis is impressive at how quick it can rotate around, so we can quickly change to the next part. On this machine we've got a Renishaw laser system, so it checks the drill isn't broken, so we know we've got complete reliability. You're tapping at around 6,000 RPM. It can do 8, but because the tap's only 3 mil deep, we can't get the acceleration. Again, roll tap, nice and reliable, makes a nice clean thread every single time. And again, we've done hundreds of thousands on this roll tap already. We're just finishing off with a 6mm cutter, just gets a really nice clean finish, and that's still at 6 meters a minute. We use a little UFO cutter to chamfer the top and the back face of the part all in one go. It's probably a little bit over the top, but it means we've got no manual finishing on this part at all, straight off the machine, straight off the anodizers. We're putting a 12mm cutter in at 24,000 RPM at 8,000 feet. So we get a really nice clean cut with lots of metal out, nice and reliable. And then we finish off with a 6mm cutter just to get a really nice clean finish on it. 24,000 revs again and 6 meters a minute. But because we've got the high revs, we get a really nice finish on it.
Now, I know that you make many products here, Neil, other than the pedals, but I don't want to dilute the message today because it's all about automation, productivity, and UK manufacturing.
The FANUC machine has put us back in control of our lead times, it's reduced costs, it's made us cost effective against Taiwan, and it's put us back in control so we can actually focus on the products rather than worrying about lead times and being let down by third-party suppliers.
It's a real success. Thanks, Neil.
Thank you.